Hello and welcome to the Intel Graphics Frame Analyzer Deep Dive video series. This video will demonstrate how to use the center panel of the tool to inspect a draw call further and analyze the resources of the selected draw call to determine where optimization efforts are best spent. While in single frame view of Graphics Frame Analyzer, select a draw call from the bar chart of the tool, and in the resource list of the center panel of the tool, you'll be able to view all the resources used by that selected draw call. These resources are grouped into three categories: input, output, and execution. Clicking on the Show All Resources button just below the resource list will allow you to visualize a table of all resources used in your selected draw call. By default, with all resources selected, you can view the ID, type, name, stage, and view of each resource. Clicking on each of these category names will allow you to sort your resources in either ascending or descending order based on that category. Clicking on the cogwheel icon next to the ID category will allow you to alter which categories are displayed by pressing the toggle button next to the category name. You can press the tile view button to display your resources by their thumbnail, similarly allowing you to sort these resources by clicking on the Sort By button, then selecting a category to sort by in the drop-down menu, and pressing the Sort Ascending toggle button to sort in ascending or descending order based on that category. You can choose to limit the resources you're viewing by the resource type, displayed in the form of tabs at the top of this panel. These types include textures, buffers, shader sets, geometry, samplers, arguments, and states. You can also filter your resources in this panel by typing in a keyword in the filter expression bar, and only the resources that contain your keyword will be displayed. Selecting a single resource will allow you to inspect the data associated with that resource in the resource viewer. By default, once a draw call is selected, you can view the texture of your render target in the resource viewer, setting what all selected events draw to a solid pink color. Above this panel is the texture viewer toolbar containing several drop-down menus allowing you to modify what's visualized in the resource viewer. The Render Target State drop-down menu allows you to toggle between Normal Mode, which displays the render target state for the last event in the render target region where the current selected render target is located, and Scrub Mode, which displays the render target state for the current selected event. The Output Texture Visualization Mode drop-down menu allows you to switch between viewing modes of the selected output texture. Current Mode shows the render target with modifications. Original Mode shows the render target without modifications. Diff Mode shows the difference between the current and original render target, and Overdraw Mode, which shows the render target with a blue scale overdraw visualization. The brighter the color, the more times the pixel was updated. It's important to mention if no experiments have been applied to your selected call, then the current mode is equal to the original mode. The Selected Calls drop-down menu allows you to alter how the selected draw call is rendered, allowing you to switch between Original, which displays what all selected events rendered without any modifications, Highlight, which displays what all selected events rendered in a pink color, Wireframe, which displays all selected events rendered in a wireframe, and Hide, which hides all selected draw calls from view. The Other Calls drop-down menu allows you to switch between options to show non-selected calls. Original renders all non-selected events without any modifications. Highlight sets all non-selected events to a solid blue color. Wireframe sets all non-selected events to a wireframe, and Hide hides all non-selected events from view. In this toolbar, you can also save a texture image or render target in either the Direct Draw Surface, Chronos Texture, or PNG formats by pressing the Save File to Texture button. You can also turn the texture or render target upside down by pressing the Flip Image button, in case you have an intermediate render target which was rendered upside down, and you can open a colored histogram of the texture or render target by pressing the Histogram button. After pressing the Histogram button, you can select a color range which contains relevant data by clicking and dragging with your mouse in the histogram, or by typing its threshold value values in the range selector just below the histogram, and the texture content will be normalized based on your specified threshold values. You can zoom out of the selected range using the mouse wheel and scroll left or right by clicking and dragging the mouse wheel while holding down the Control key on your keyboard. To return to the default range, click on the Reset button below the range selector, and you will notice how your histogram values change according to the texture format. You can hover over or select a pixel in your texture to view detailed information about the pixel values just below the histogram, displaying the original values used to store pixel information in memory and the normalized values used in shaders. Selecting a pixel of your texture will populate the Pixel History tab of the API log. In this tab, you can view the events that affected that selected pixel and visualize colored boxes next to each call to demonstrate the color written into the frame buffer after the API call's execution. If the call had been rejected at one of the pipeline stages, then the box will be white with a gray line running through it. For 3D textures with MIP maps, and texture arrays, you can select a sub-resource in the MIP level selector or layer selector. It's important to mention that grayed out values in the MIP level selector or layer selector mean that the corresponding sub-resources do not address or use these levels in the selected resource view. For cube map textures, you can open one face of a cube map by selecting from the drop-down list and selecting the desired face. The default option is a cube map layout. Selecting a buffer from your resource list will open the buffer viewer, displaying a detailed table or list of your buffer data. Pressing the View button will allow you to toggle between list and table view of the buffer viewer. Clicking on the Layout field next to this button will allow you to view and edit the open buffer layout, written in buffer markup language. Pressing the Restore Default Layout button will allow you to revert any layout changes made and restores the default shader defined, pipeline state defined, or default buffer layout format if the buffer layout was not received from the shader. Pressing the Info button will display detailed buffer markup language information to aid in making layout changes using the Layout field where layouts are extracted from a shader automatically if possible. Selecting a shader set from your resource list will open the Shader Set viewer. In this panel, you can view and modify the code from your shaders by selecting a shader from the Shader Code drop-down menu and selecting one of the following options: HLSL source code for DirectX or Vulkan applications, or GLSL source code for Vulkan or OpenGL applications, assembly code for Intel GPUs, and the compiler flags when compiling your shaders directly in Graphics Frame Analyzer. Once you have selected the shader you want to modify, the shader editor opens, allowing you to modify the code directly in Graphics Frame Analyzer. It's important to mention that only HLSL and GLSL source code can be modified using the shader editor. Press the Format button to indent your code, and the Preprocess button to preprocess the selected shader and hide code paths that do not get executed. Pressing the Load Source Code button will allow you to add your source code directly into Graphics Frame Analyzer for modifications. You can modify your frame's shader code by typing directly into the shader viewer, and the code recompiles during the process. If you have encountered any errors while editing the code, the corresponding error message can be seen in the notifications pane below the shader editor. If your code is free of errors, you can press the checkmark icon to save your changes, and Graphics Frame Analyzer will then recalculate all metrics and display new data in the metrics panel and in the main bar chart. To display the shader resource list, which allows you to analyze the resources used in the shaders grouped by type, click on the Bindings button. You can view the pixel or vertex shaders by selecting from the drop-down menu next to the Bindings button. In the shader resource list, you can view the shader's name, the shader register, and the resource binding. To open a resource, click on the resource binding. For enhanced profiling of your shaders, you can use the Shader Profiler feature by clicking on the Hotspot button in the shader view. It's important to note that if you want to profile HLSL or GLSL source code, you must compile your shader with debug information using the D3D compile debug flag. You can select either a pixel or a vertex shader for profiling, and a list of SIMD versions used during rendering are displayed after pressing the Show Source Assembly Mapping button. Choose a SIMD version to view Gen ISA code with profiling information. Then select Duration or Execution Count from the drop-down menu to further analyze the efficiency of your shaders. Selecting a geometry resource from your resource list will allow you to visualize the mesh for that selected draw call. In the Visualization Mode drop-down list, you can switch between viewing modes to analyze the geometry aspects of your selected geometry object. You can set your geometry model to Solid, which displays the object as a solid model, Wireframe, which displays the object as a wireframe model to inspect the backside of the object and understand how dense the object meshes, Solid Wireframe, which displays a wireframe model on top of the solid model, and Normals, which displays a normal map in the object space. The Output Geometry View drop-down menu next to this one allows you to toggle between a Post-Transform Mesh mode, which displays the object with transformed vertices, and a Screen Space View mode, which displays a projected object to a 2D screen space. While inspecting your geometry object in Post-Transform Mesh mode, you can rotate the object in any direction by holding down your left mouse button. To move your geometry object within the screen space, right-click on the geometry object. To flip the axes, middle-click on the geometry object. You can export your geometry data in Wavefront OBJ format by clicking on the Save Geometry to File button. You can click on the Geometry Layout button to display details of your geometry, including general information like topology and bounding boxes, as well as attached vertex buffers and their layouts. Selecting a sampler resource from your resource list will display a table of read-only settings for your sampling textures. To the left of this table, you can view all the samplers in your selected draw call and navigate through them. Selecting an argument from your resource list will display the list of arguments of the selected graphics API function, as well as the data associated with that function. It's important to note that this viewer only shows data for a single function. Selecting a state resource will display the graphics pipeline or compute pipeline viewer, showing settings for fixed function blocks of the graphics or compute pipeline. You can press the toggle button to turn groups of data on or off. For DirectX and OpenGL applications, the state viewer displays API agnostic data, which can be modified for several draw calls simultaneously. Settings with a down arrow next to them can be modified by clicking on that setting and selecting from the drop-down menu that pops up underneath it. If your application uses DirectX 12 or Vulkan, you can explore the internals of DirectX 12 root signatures or Vulkan descriptor sets, which are useful for debugging. There are a few more user interface features that are worth mentioning while inspecting resources using the resource viewer, allowing you to open the previous selected resource by pressing the previous button, open the next selected resource by pressing the next button, display the resource viewer in a separate window by pressing the Show Resource in Separate Window button, and populate the Resource History tab of the API log pane to display events that were used in the selected resource by pressing the Resource History button. If you're interested in learning more about how to identify and analyze problem areas in your applications to resolve GPU performance regressions, continue watching our Graphics Frame Analyzer deep dive video series. Thank you for watching. Make sure you like this video and subscribe to our YouTube channel for new exciting GPI updates and get started optimizing your games today.